Good morning, Course 2. We are now on Lesson 103. We'll be covering the powers of negative numbers, dividing terms, and the square roots of monomials. So today we're going to start out with example 1 in our book, and as you can see, there's 1, 2, 3, 4, 5 terms. And so there are two ways to actually do this problem. We could start on the left-hand side and multiply positive 3 times positive 4, which gives us positive 12. And then we'd multiply positive 12 times negative 5, which would give us negative 60. And then we'd have negative 60 times negative 2, which would give us positive 120. Positive 120 times negative 3 would give us negative 360. There's another way to do it that would make it simpler, and I'd like to teach you the simplified method. Whenever there are even numbers of negatives, your answer is going to be even. Your answer is going to be positive. Whenever there are even numbers of negative signs, your answer will be positive. Whenever there are uneven numbers of negative signs, your answer will be negative. So looking at this problem, we can see we have 5 different terms. 2 of those are positive, and so that remains positive. 3 of those signs are negative. Since 3 is an odd number, I know that my final answer is going to be negative because there's 1, 2, 3. Negative times negative is positive. Positive times negative is negative. So the rule is even numbers of negative signs, the answer will be positive. Odd numbers of negative signs, the answer will be negative. Then you just have to go back and worry about the multiplication. You don't have to worry about whether your answer is going to turn up negative or positive. So 3 times 4 is 12. 12 times 5 is 60. 60 times 2 is 120. And 3 times 120 will give us 360. Because we already figured out 1, 2, 3 odd negative signs, we know that our answer is going to be negative. All right, our next problem in example 2, they want us to simplify these two factors. So if I'm going to have negative 2 to the 4th power means negative 2 times negative 2 times negative 2 times negative 2. That's what it means. I have 1, 2, 3, 4 negative signs. What I just taught you is that answer is going to end up being positive. So now I just have to go back and multiply 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16. So my answer for A is going to be positive 16. This second one, negative 2 to the 5th power means negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And here I have 1, 2, 3, 4, 5 terms that I'm going to be multiplying. There's 1, 2, 3, 4, 5 negative signs. That tells me, because it's odd, that I'm going to have a negative answer. Again, 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. 2 times 16 is 32. So my answer is going to be a negative 32. Here's my answers. That's the quick version on how to use those negative signs. Now we're going to apply them in some different ways. But first, we're going to actually be figuring out how to divide a problem like this. Notice it's 12x to the 3rd y z squared over 3x squared y. The first thing we're going to do is separate these numbers into their prime factors. The prime factorization of 12 is 2 times 2, which is 4, times 3, that's 12. And then I'm going to expand my x to the third power. And notice I've got 1, 2, 3. There's a multiplication sign between each one of these. Then I have 1y and I have 2 z's. So there is the top term expanded. Now on the bottom, I have 3 times x, there's 2 of them, times y. Now when you're going to divide an unusual number like this, you basically line them up like this, and you can find terms that match above the line with below the line. And we know that any term that matches, like 3 over 3 is the same as 1. So they cancel out. That means that y over y is the same as 1. They cancel. I mean, that was x. X over x cancels. X over x cancels again. And here's a y over y, which will also cancel. Now, there's nothing left on the bottom because these are all 1 times 1 times 1 times 1, which would equal 1. On the top, we have some numbers and letters left. So we have first 2 times 2. And then there is an x that is not canceled out. And there are 2 z's which are not canceled out. So when we recombine that, we have 2 times 2 is 4. We have only 1 x. And then we have z squared. And this is going to be your answer. So you're looking for terms on the top and the bottom which match up, and you cancel them out. All right, example 4. We're going to do the same thing. Prime factorization of 10 is 2 times 5. We have 3a's, so a times a times a. We have 1b, and then we have 2 c's. I've expanded that out all the way. Down here, I have an 8, and 8 is 2 times 2 times 2 times a times b, because there are 2 of them, times c. So now I'm going to look for matching things that can cancel out. So here's 2 2's, so they cancel. The 5 and the 2's no longer cancel. Here's an a and an a, so they can cancel. Here's a b and a b, so that cancels. And then there's a c and a c, and that cancels. All right, now we go back and we figure out what we have left. On the top, we have 5, and then we have a, and there's 2 of them, so squared, times c. On the bottom, we have 2 times 2, which is 4. The a's are gone, and the b is there. There's no c. So it's 5a squared c over 4b. And that is going to be my answer to that division problem. Okay, in example 5, they're asking you which of these monomials, each one of these is a monomial, is a perfect square. Well, for something to be a perfect square, every piece of it has to be a perfect square. So if I look here and I were to expand this 2 times 2 times 2, I can see right away 8 is not a perfect square because these 2 would make a perfect square, but that one doesn't. Then we have x squared, y to the 4th. They could both be broken down by 2's, but this 8 makes it so that's not the answer. Here we have 2 times 2. That part is a perfect square, but x to the 3rd is odd, and so is y odd. And so that one is also not going to be my perfect square. Here, if I were to break this down into perfect squares, I could say, well, this is 6 times 6, 36. And this is x times x and y squared times y squared. Notice I have 2 of those, I have 2 of those, and I have 2 of those. That makes this the perfect square. And on the next example, we will actually take those and do the square root. So here we are in example 6. And to figure this out, we would want to expand this number in a way that would make it easy to solve. You could expand it all the way, but we can see what this is. 36 is 6 times 6. X squared would be x times x. And y to the fourth would be y squared times y squared. Now, with a square root, you have to have two matching parts, which we have two matching parts for all three of these, but you only take one out. So I would have 6 x y squared. That would be the square root of this number. There's two 6's, but I only bring one out. There's two x's, but I only bring one out. And there's two y's, but I bring one of the y squareds out. All right, let's start our practice set. Looking at A, we have -5 times -4 times -3 times -2 times -1. All right, in looking at this right away, I want to figure out whether this is going to be positive or negative. These are all multiplied. This only works with multiplication and divisions. I'm going to count 1, 2, 3, 4, 5. All right, it's an odd number. That tells me my answer is going to be negative. I just know my answer is going to be negative. So now I just go back and deal with the numbers. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. And 120 times 1 is going to be negative 120. And that will be my answer for A. Looking at letter B, I have a +5 times a -4 times a +3 times a -2 times a +1. All right, so let's count up our negative numbers. 1, 2. Okay, that's an even set. And so my answer to this is going to be positive because I know it's got an even number of negative signs. So now I'm just multiplying. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. So there is my answer for B. Letter C has -2 to the third power. So that's the same as -2 times -2 times -2. That's the third power. So I'm counting up my negative signs. I have 1, 2, 3. That tells me my answer is going to be negative. And then I go back and do the actual multiplication. 2 times 2 is 4. 2 times 4 is 8. And there is my answer. My answer is -8. Let's look at D. -3 to the fourth power. So that means -3 times -3 times -3 times -3. So I'm counting up my negative sides. 1, 2, 3, 4. That is an even number. So that tells me my answer is going to be positive. And now I'm going to multiply. Well, 3 times 3 is 9. 3 times 9 is 27. And 3 times 27 is 81. So my answer is going to be positive 81. Another way you could look at it is 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Okay, let's look at E. E is -9 squared. That means I have -9. Whoops, I put that in the wrong side. -9 times -9. I have two of them. So there's two negative signs. That means my answer is going to be positive. 9 times 9 is positive 81. Letter F. -1 to the 5th power. That means -1 times -1 times -1 times -1 times -1. So I should have 1, 2, 3, 4, 5. All right, so 5 negative signs, that's odd. That tells me my answer will be negative. And 1 times 1 times 1 times 1 times 1 is 1. My answer ends up being -1. Okay, let's look at letter G. This one is 6a squared b to the 3rd c over 3ab. All right, we're going to break this down into pieces. So the prime factorization of 6 is 2 times 3, and then we have 2 a's, a times a, 3 b's, 1, 2, 3, and I'm running off the side of the paper, and a c. And that's going to be over 3 times a times b. So I'm looking for things that match up. Here is a 3, so these cancel. Here is an a, that cancels. Here is a b, so those cancel. So now on my bottom, I have 1 times 1 times 1. So it's no longer going to be a fraction. It's just going to be a single number. So now I have 2 on the top. I have 1a. I have 2b, so that's b squared c. So that is going to be my answer. Okay, letter H, same thing. 8x y to the 3rd z squared over 6x squared y. So I'm going to break it down. The prime factorization of 8 is 2 times 2 times 2. Then times x times 3 y's. And then there's 2 z's. Over. 6 breaks down into 2 times 3. Then there's x times x times 1y. All right, I match up what comes together. 2 over 2, that cancels. 1x over x, that cancels. 1y over y, those cancel. So now I go back and figure out I've got 2 times 2, which is 4 on the top. I have no x's left. I have 2y, so it's y squared, and 2 z's, z squared. And on the bottom, I have a 3 and an x. So that is going to be my answer when I complete the division. Okay, letter I. 15m n squared p over 25 m squared n squared. All right, we're going to break it up. This one's going to be 3 times 5. Then there's an m, and then there's 2 n's and a p. Draw my division line. 25 is 5 times 5 in prime numbers. Then there's 2 m's and 2 n's. Oop, that's not an n. Oop, n. Okay, so now we're going to match things up. Here's a 5 and a 5. They cancel each other. Here's an m and an m. They cancel each other. Here's an n and an n that cancels. And then there's another n and n that cancels. Okay, what do I have left? On the top, I have 3. These are all canceled. P over. I have a 5 left and an m left. That is going to be my complete answer right there. Okay, we're almost done with the practice set. Now for J and M, through M, we want to state whether the monomial is a perfect square. If it's a perfect square, we're supposed to figure out what the square root is. So let's start with, what happened? Let's start with J. J is 12x squared y to the fourth. Okay, so our first question on J is 12 a square root? Well, if we break it down to its prime factors, it's 2 times 2 times 3, it's not a square root. So even though these are actual square roots, this disqualifies it. So this one is not a square root. Okay, let's look at K now. K has 49 a squared b to the sixth c to the fourth. All right, is 49 a square number? Well, it is. It's 7 times 7, right? A squared, well, that could be separated into a times a. B to the sixth, we can split that in half and we'd have b to the third times b to the third, because you add those together, it's b to the sixth. And the last one, you'd have c squared times c squared. So if I were to pull one from each of these, here's one group, second group, third group, fourth group. I take out one 7, I take out one a, I take out one b3, and I take out one c squared, and that shows that it is a perfect square, and that is its square root. All right, let's look at L. L is x to the sixth y squared. So if I break these into 2, I want to make it into 2. So this could be x to the third times x to the third times y times y. Okay, so now here is a identical pair and here is an identical pair. So I pull one of them out, x to the third, and pull one of those out, y. This is going to be our square root answer. And now for M, we have 16 a squared b to the third. If we break this up, we can, 16 is a square root, it's 4 times 4. If I break this into 2 pieces, it's a times a. And if I break this into 2 pieces, it's b squared times b. Okay, this does not fit the square root mode. So this one is not a square root. Okay, if that's giving you any trouble, make sure you call me so we can talk it through. We're going to keep working through all this. Make sure you do your lesson and get it turned in. I'll see you tomorrow with lesson 104.